Hey, very good morning, students. Let us look into our next topic called Master Slave JK Flip Flop. This Master Slave JK Flip Flop is an extension of JK Flip Flop. The main drawback of JK Flip Flop is race around condition. What is race around condition is when J is and K is 1, when clock is 1, the output keeps on changing from 0 to 1. So when J is 1, K is 1, output keeps on changing from 0 to 1 or 1 to 0. It is not stable. You call that as toggling condition. When J is 1, K is 1, clock is 1, the output is unstable, keeps on changing or toggling or output oscillates. Such condition is called race around condition. To avoid that condition, we go for master slave JK flip flop. In master slave JK flip flop, we make use of JK flip flop. We remove or take the feedback path of J and K eliminated. Can you see the blue feedback is eliminated and JK circuit is taken as such. Since it is master slave, I make use of two JK flip flops without feedback. So this is my first flip flop. I take again one more JK flip flop and have my slave. So my first JK is called as master. My second JK is called as slave. I connect the output of master as an input to slave. I connect the output of master as an input to slave. Now tell me my circuit master slave JK flip-flop has two inputs J and K and two outputs Q and Q bar. We know JK flip-flop has three inputs. So what we do? Qn bar is stay slaves. Slaves Qn bar is connected to J. Slaves Qn is connected to K. This is the construction. Apart from this, we have missed the clock. The clock input is inverted and given to the slave's clock. So clock input of masters is inverted and connected to the slave input of clock. This is the construction of master slave JK flip-flop. For this, I need two JK flip-flops. I need two JK flip-flops without the feedback. Okay. Then what I do, I take the output of one flip-flop master and connect it to the input of slave. Output of master connect to the input of slave. Invert the clock of master and connect it to the clock of slave. Output of slave Qn bar is connected to J, one input of first flip-flop. Qn is connected to the one input of the first NAND gate. Okay, this is what the construction of master slave JK flip flop. Now let us see the working. We know this is the master slave JK flip flop. We know when clock is 1. Can you see when clock is 1, what happens? This 1 passes through this wire. Since there is a NOT gate, output of this will be 0. This 0 will comes to the clock of slave. So clock is 1 in master, it becomes 0 in slave because of this inverter gate. So whenever clock is 1, master is on. If clock is 0, slave is off. It means at any point of time only one flip-flop will be on, the other flip-flop will be off. Suppose if clock is 0, what happens? If clock is 0, if clock is 0, what happens? 0 get inverted, you get clock here 1. So since clock is 0 here, master is off. Clock is 1 here, slave is on. Let us see the working. So, we need to be very careful in the working. Can you see if clock is 1? If clock is 1, master is on, slave is off. Done. So whatever be the inputs, J can be 1 or 0, K can be 1 or 0. If clock is 1, you get the outputs as QM and QM bar. Right? Now this QM and QM bar is given to the output of master is given to the input of slave. Since the clock is 0, the slave is not working. The output is staying in the master only. When clock is 1, the output is staying in the master only. So what is the output? QM, QM bar. Okay. If the clock, then the clock becomes 0. When the clock becomes 0, what happens? The master will be off and slave will be on. Since slave is on, what happens? The output of master is propagated to the slave's input. Output of master is given as a slave input. Since slave is on, what is the job of slave? To propagate the output of master to the output terminal. So the output of slave Qn and Qn bar will be Qm and Qm bar. What is the job of slave? Slave propagates the master output. Okay. Yes. So that is why we call this fellow a slave, and the first JK flip-flop is master. Now see the change. Now see the output is connected in feedback to the master. Now can you see, whenever the slave is on, what is the job of slave? To propagate the output of master to the output terminal. Propagate the output to the output terminal. Whenever the output terminal is changed, since it is connected in feedback, it will not, what happens, since master is off, the feedback breaks, so there will not be any impact on it. Due to this, we avoid what? Race around condition. The output would be stable. The output will not toggle from 0 to 1 or 1 to 0. The output will not oscillate. That is how master slave JK flip-flop will avoid the race around condition. I repeat, since master slave JK flip-flop works in a mode where at any point of time only one flip-flop will be on, other flip-flop will be off. Due to this, there will not be any feedback, right? So the feedback connection will get break. So what happens, though there is a change in the next state, that will not be propagated to master because it is in off state. So this will eliminate a condition called race around condition. Let us see the working condition. J is 1, K is 1, Qn is 1, Qn bar is 0. It means J is 1, K is 1, Qn is 1, Qn bar is 0. For this condition, we will see how the master slave JK flip-flop works. You know, when J is 1, K is 1, clock is 1. Can you see this 1 gets propagated here? This 1 gets propagated here. So Qn is 1. This is assumption. Qn is 1. Qn bar automatically will be 0. So Qn bar is propagated to J. Qn is propagated to K. Okay. 0 into 1 into 1, 0, 0 complement is 1. So 1 into 1 into 1, 1, 1 complement is 0. When any input of the NAND gate is 0, the output is 1. We know that. So since this input is 0, output is 1. Now what we need to do is, now Qm bar is 1. If I propagate this here, 1 into 1 is 0, 0 complement is 1. So I got the output Qm as 0, Qm bar as 1. This is clock is 1. Now this clock here, slave is passed through the inverter. So slave becomes what? 0. So this is not working. So in the next state, what happens when clock is 0 and what happens? Master will be off and slave will be on. During that time, what happens? The slave will take the master's output. Okay, now Qm is 0, Qm bar is 1, clock is 1. 1 into 0 is 0, 0 complement is 1. It means when any of the one input to a NAND gate is 0, output is 1. When both the inputs are 1 into 1, 1, 1 complement is 0. When any of the input to a NAND gate is 0, output is 1. So pass that 1 here. 1 into 1, 1, 1 complement is 0. It means I have got what? My new, can you see my Qn? I have got 0. Qn plus n bar, I got 1. It means Qm value I have propagated from master to slave, master terminal to slave terminal. So this is the truth table of JK flip-flop. When J and K both are 0, 0, there is no change. When it is K is 1, it means K terminal is similar to reset terminal, J terminal is similar to set. When K is 1, reset is 1, output is resetted, 0. When J is 1, set is 1, output is set. So it is 1. When both are 1, 1, what is happening? Qn, previously it was 1, now it has become what? 0. Qn bar previously was 0, now it has become what? 1. So what is the output you get? You get invert to Qn. That is why we have written here Q complement n. So this is the truth table of JK flip-flop. Thank you.